Okay class, this is the video for class example 27 and 28. So let's read the class example 27 first. It says that a 3-acre park in an urban area is covered by the grass. Okay, so if it's grass, that means it's the pervious, right? It's not the impervious one. The soil is sandy loam with 0.5% organic matter content. The flow length is 400 feet and the slope in the flow direction is 0.001. Determine the suspended solid load from this park resulting from a 3-hour rain in which the intensity distribution is given in column 1 and column 2 of table 8.4. So this is the column 1, this is the table column 2, and you can see for every 30 minutes what is the intensity. That's what is given here. So let's draw a schematic diagram first and then work with, okay, what will be the total suspended solid. Okay, so since it says that the flow length is 400 feet, so if I try to draw, that is the flow and the length of this one is 400 feet and the S naught is 0.001. Now for that flow within that 400 feet, we need to find out what is the total amount of suspended solid. Now if you can remember, there are two types of pollutant wash off. One was for impervious and one is for pervious. Here we are working with the pervious one. So for pervious one, we basically find out what will be the total loss, like soil loss equation, or what will be the amount of erosion on that area. So that's what we will do, and we need to find out the delta P. Just one thing, that 2000, that is kind of unit conversion, and delta P should be in pounds, okay, and A should be in acres. So those are just few things you need to maintain. Now let's work with that one. So since we are trying to find delta P, we need to find out AP, R, K, LS, C, PF, so many factors. Okay, and I already set up the table here. For your copy it's not there, so you need to type that one. So we are trying to find delta P, and then we will find out what is the rate of that load. So delta P over delta T. Okay, that is fine. So let's work with delta P. The very first thing is we need to find out what is the area, right? So the area is 3, because that one was given here, 3 acre. What is the R, what is the K, what is the LSC and PF? Okay, so let's see. The very first thing I'm seeing here, which is the cropping management factor C, it's 0.003 for grass cover. Okay, so our C here, this one will be 0.003. Okay, one thing is done. Then the erosion control practice factor, for urban area it's 1. So I'm actually doing the easier one first, and then I will do all the calculation. Okay, so that is 1. Now for the LS, K, R. Okay, so let's see what else we can find. Okay, I'm seeing the K here, soil erodibility factor, K in tons per acre. Okay, so it will depend on different types of soil. So we have sandy loam with 0.5 organic matter, sandy loam here 0.5. okay, so that means the K will be 0.27. okay, what about, so now we need to know LS and R. Okay, let's see what do we have for LS. Okay, the slope length gradient ratio LS, it's an empirical function of the flow length and the surface slope. It is calculated using L to the power 0.5, 0.0076, 0.753 S and 0.76 s square. Okay, so what we will do for this one, we will write down here what is the L, 400, right? So 400.5.0076.53, what is the S value, and 0.76, that S square. Okay, so that's what we will find out. And if you do the calculation here, it will be like that. Okay, since the S is same, nothing will like for any time the LS will be same. Okay, now the only thing we need to know is R. Okay, so let's see what do we have for R. Okay, so single storm rainfall factor R, we have this one, and we have an empirical equation here as well. Now to need to use the table 8.3, you need to know the location, which we don't know, so I can't use the 8.3, but I have another equation which is R E I30. Now the question is, what is I30? So the I30 is the maximum average 30-minute rainfall intensity in inch per hour for the storm. Okay, and the E is 9.16, 3.31 log I. I is the intensity, delta T is the time, which is its time increment in hour, so 0.5. Okay, so let's find out the I30. Which one is the maximum? Here 1.3 is the maximum one, that is the I30. And we need to find out the E first. Okay, so and then we can find out the R. So E first, it will be like 9.16, 3.31 log I, whatever I you have for that specific one, multiply with I, multiply with delta T is 0.5, and once you find that E, multiplied with 1.3, because 1.3 is the maximum one. Okay, so if I use this one to do the E calculation, okay, so what is the way to do that? Okay, now it is creating some problem. Okay, I don't want that. Okay, so maybe I need to remove these, and then Okay, so find out the something is happening here. Okay, so this one will be the E, and once you have the E, you can actually find out the R, and now you have everything, so multiply everything in between these, and if you divide that by 0.5, that is the W. Okay, so for this question, for that 3 acre at each 0.5 time increment, that is the load. Okay, and that is the suspended loaded solid load from this part resulting from a 3-hour rain. Okay, so let's start with the class example 28. So here we need to find out average loading in the concentration of BOD suspended solid Vs PO4N of a 60 acre commercial area. Okay, commercial area served by a separate storm sewer, okay, and the sanitary sewer system. About 39 acres are covered by impervious surface. The streets are swept once a month. The average annual precipitation is 36 inches. Okay, so I was a little bit wrong in my class lecture. So when I said the swept factor, I said that it will be because of the rainfall. Basically, it's like obviously like for each street, like urban street, they do a big cleanup like once in a month or something like that. So that's when they usually remove all the materials and everything. So that's what it is. And the average annual precipitation is 36. There is one more thing, which is the total runoff volume is 4.72 into 10 to the power 6 feet cube. Okay, now there are few things we need to consider. The very first thing is this one is the separate storm sewer, it is not the combined one, so that will be our equation. Another thing is we are working with the commercial area here. Okay, so since we are looking for ms alpha p fs, our very first thing should be to set up the table and do all the units here. Okay, and what we will do, the ms, and then we will find the total load. Like instead of per acre, we will find, okay, since we know the area, what is the total load, and instead of lb per year, we'll find the concentration, which is lb per feet cube. Okay, so let's work with that. The very first thing we need to know the alpha, right? And since this one is the commercial, this is our thing, this one, this one, this one, this one, this one. Okay, so what we will do, that is the alpha you have. Okay, now the p is annual precipitation in inches, which is 36 inches. Okay, which is good. Okay, then the f and s, f is the population density function. Okay, let's see if we have anything for the population density function. For commercial areas, okay, the equation is missing here, but if you check your class note, you will see for the commercial and industrial use, f is actually 1. Okay, so that's what we will do here. The s is street sweeping factor, which depends on what is the frequency of sweeping that. If the ns is more than 20 days, I think the s is something, and if the ns is less than 20 days, this one is just 1. So more than 20 days, it's I think s over 20, which is not the case. For our case, these one, oh, once in a month. So I'm sorry, so if it's more than 20 days, the S is 1, and I think if it's less than 20 days, it was S over 20, something like that. So since we have our NS is more than 20 days, we will have S equals to 1 as well. Okay, now we can find the MS, which is multiplying all of these. Now how can we find out the total loading? Basically this one will be MS multiplied with 65. That one will be the total loading. Now the next thing is, okay, that's what we got for pound per year. How can we find out what is the concentration? Okay, so the C is actually total load over runoff. Okay, that's when you can find LB over feet cube. Now how can I find out the total load? I already have load per year. I will just divide this load by that 4.72 10 to the power 6. You can see that here. Okay, okay, now we have all the values for that commercial area. If we use the separate storms here, those will be the concentration of each pollutants annually. Okay, so that is the class example 28. So thank you. Please go through these class examples and let me know if you have any question. Bye.